So now we're going to start talking about polynomials. We're going to learn a lot of different things about polynomials so that we can graph them. So first of all, a polynomial is of the form f of x is equal to a sub n x to the nth power plus a sub n minus 1 x to the n minus 1 power, going on until we finally get to a sub 1 x plus a sub 0. And you probably look at that and go, well, I don't know what that means. So here's the thing to look for when you're looking at a polynomial. It's going to have one variable throughout the whole thing, and all of the powers that are on our variable, which will generally be x, are counting numbers or 0. So numbers like 1, 2, 3, 4, 5, and 0. Okay, so let's look at some examples. Notice that throughout our variable is an x, and all of our exponents are counting numbers. So 4, 7, and of course the unwritten exponent on x is a 1. All right, so this is an example of a polynomial. And we can have a number out to the side as well. Okay, so notice this one is also a polynomial. 20 is a counting number, 9 is a counting number, 2 is a counting number, and of course 1 on that's not written on this x is a counting number. Okay, so let's learn a few other things about these polynomials. The degree of a polynomial is its highest exponent. All right, so in other words, if I go back to the two examples I had here, and let me just use a different color. If we look at the highest exponent, on this first one, it's 7. So the degree of this polynomial is 7. The degree of this polynomial is 20. Okay, so the highest exponent. Now, let's get another definition. A power function is a one-term polynomial. And we've already seen some power functions already. We saw a library function of x squared, and it's a power function because it only has one term. And we know what it looks like. We know that this is the graph of a parabola. All right. Now, we know from our transformations that if we put a negative in front of our parabola, it turns it upside down. This is another power function. So it becomes an upside down parabola. We know what x cubed looks like. That was one of our library functions as well. I'll do it in a different color. Remember that looks kind of like this. Okay. And we know if we put a negative in front of it, it would flip this over. And so if it flipped it over, it would look like this. All right. So we're going to need these 4 graphs that I just did to describe something called end behavior. The end behavior of a function describes where it's going on the far right and the far left. Let's notice, for example, that x squared on the far right, so if I go over here to the right, is going up forever. So as my x values go to the right, as my x values go to infinity, my y values are also going up forever to infinity. On the other hand, if we look at this one, as my x values get bigger out here to the right, my y values are going down forever. So my x values are going to infinity, but my y values are going to negative infinity. And if we look at x cubed, as my x values get bigger out here on the right-hand side, my y values also get bigger. They go to infinity. If I go the opposite way, though, as my x values go to negative infinity out on the left side, my y values go to negative infinity. And if we look at negative x cubed, as my x values get bigger out here to the right, my y values go down forever into negative infinity. And the opposite is true over here. As my x values go into negative infinity, as they get smaller and smaller to the left, the y values go forever upward or go into positive infinity. This is called end behavior. Now it turns out if we look at the highest powered term, which is called our leading term, the highest powered term. on a regular polynomial, that's going to determine its end behavior. If the term has a positive number in front and an even exponent, like x squared, it's going to behave like x squared. In other words, both its left and its right-hand side are going to be going up forever. If it has a negative in front of it and an even exponent, like negative x squared, it's going to behave like negative x squared. Both the left and the right side will be going down. Now, let's note that it could be doing all kinds of things in between, but on the far left and the far right, it will go down. All right? If the term has a positive in front and an odd exponent, like x cubed, it's going to behave like x cubed. So it's going to be going up on the right and down on the left, on the far extremes. Could be doing all kinds of stuff in here. And then finally, if the term has a negative in front and an odd exponent, like negative x to the third, it will behave like negative x to the third. So in other words, on the far left, it'll go up, and on the far right, it'll go down. So, in other words, let's go back to the two examples that I had up here. In these two polynomials, I'm going to erase what I've got there. We know that was the degree, but let's look at the leading term is the term with the highest exponent. So here's the leading term of this function. It has a negative in front and an odd exponent. So a negative in front and an odd exponent will behave like negative x to the third, which means it will go up on the left and down on the right. So let's sort of summarize that. When I go to the left, my x values are going to negative infinity. So as x goes to negative infinity, so I'm going to negative infinity when I go to the left. Notice though my y values are going up, so y is going to positive infinity. On the other hand, on the other side, as x goes to the right, so as x goes to positive infinity, notice my y values are going down forever, so y goes to negative infinity. All right, now let's look at the second function and get its end behavior. Let's notice its leading term is the term with the highest exponent. There's a positive in front, and this exponent is even. So positive and even is going to be the x squared. It's going to look like x squared on its ends. It's going to go up on both sides. So as x goes to the right, so as x goes to infinity, it will go up forever, so y will also go to infinity. And as x goes to the negative side, to negative infinity, y will also go to, well, not to negative infinity. Y is going up forever, so y will go to positive infinity, just like it did on the right side.